Hello Algebra 1 students, this is Mr. Wilson, and in this video we are going to continue looking at solving quadratic equations, just like we did in the last video. However, we're going to look at equations that are a little bit more complicated. But before we get into solving quadratic equations, I want to preface this with a new property, okay? So, let's talk about the zero product property. Now, let's say we have A times B. If A times B is equal to 0, the zero product property says that either A is 0 or B is 0, or possibly both. Does that kind of make sense? If you multiply anything by 0, you're going to get 0, okay? So if you ever see an equation of that form, something times something equals 0, one of the somethings have to be 0. Now, for example, if you see an equation that looks like this, let's say in parentheses x plus 2 times x plus 3, if that was equal to 0, if this product is equal to 0, then you know that either x plus 2 is 0 or x plus 3 is 0. Does that sort of make sense? Now let's see where this could come in handy. If the directions for this problem were solve for x, then the way that we can solve an equation like this for x is to split it into two separate equations. Split it into two separate equations. Now these two equations, we can easily solve these individually, right? Over here, simply subtract 2 to get x is negative 2. Over here, subtract 3, so x is negative 3. So the solutions to this equation are x equals negative 2 or x equals negative 3. There are two possible numbers that will make this product equal to 0, that will solve this equation. Let's take a look at another example of that. So example 2. This was example 1, of course. What if I ask you to solve this equation? Solve for t. Now in parentheses, 4 times t plus 1 times, in parentheses, t minus 2 equals 0. So if you see an equation like this, and we are asked to solve for t, that means find the numbers that we can stick in for t that will make that equation true. And the way that you solve that equation is by utilizing the zero product property. Okay? If that product is 0, then that means that either 4t plus 1 equals 0 or t minus 2 equals 0. And then from here, we can solve each of these equations individually. On the left-hand side, we can subtract 1 from both sides. So 4t equals negative 1. And then divide both sides by 4. So t could be negative 1/4. Or we could add 2 to both sides on this equation. T equals positive 2. Okay? So the two numbers that we could stick in for t to make that equation true are t equals negative 1/4 or t equals 2. Now you might be asking, why do we care about the zero product property? Why do we care? Well, you still might not care after I explain this to you, but I'm going to give it my best shot. to explain why we care. In the last video, you learned how to solve equations like this. Let's say x squared minus 9 equals 0. If you were asked to solve that equation, you now know how to solve that equation. All you have to do is add 9 to both sides and then square root, right? You can solve this type of equation by square rooting. Or you could solve it by graphing. Either way will work. But now we're going to look at equations that look like this, for example. In this video, we're going to try to solve equations that look like this. X squared plus 8x plus 15. Just as an example. That equals 0. Now, what is the difference between these two equations? There's lots of different differences, but the most important one is right here. There is an x term. Over here, there is no x term. So when you don't have an x term, you can solve it by square rooting. If you do have an x term, you cannot solve it by square rooting. Do you kind of see why? Because there's no way to isolate well, you could isolate the x squared term, but then you'll have 8x on the other side of the equation, and that won't allow you to isolate x itself by square rooting. So we have to learn a new way to solve equations that look like this. And we're going to use the zero product property. Now we know that the zero product property will allow us to do this. If we can somehow write a product, so two things multiplied together, if we can write something like this equal to 0, then we can use the zero product property to split that into two different equations. Now you know how to do that. You know how to take something that looks like that and write it as a product. Do you remember how we did that? How do we get from here to here? Well, that's called factoring. You should be a pro at factoring by now. So in order to solve an equation like this, what we have to do is solve by factoring. So go back up to the title of your notes, Solving Quadratic Equations by Factoring. That's what we're going to look at in this video. Now, let's factor this real quick. First question is, can we use the shortcut? Well, yes, we can use the shortcut because there's an invisible 1 out here. So that means that all we need to do is find the magic pair of numbers that multiply to give 15 and add equal 8. So let's see, 15 could be 1 and 15, negative 1 and negative 15, 2 and, no, not 2. How about 3 and 5, negative 3 and negative 5, okay? These are all the factor pairs of 15. Which pair adds up to 8? Well, this one. 3 plus 5 equals 8. That means that the way to factor this guy is simply x plus 3 times x plus 5. There we go. So we have successfully written this sum as a product. And now, in order to continue solving it for x, we split it into two equations using the zero product property. We split it into two equations. The zero product property says that either x plus 3 is 0 or x plus 5 is 0. And so from here, clearly, you can see that either x equals negative 3 or x equals negative 5. Those are the two numbers that will make that equation true. Let's just check that. Let's just check that. Check. So first of all, let's test x equals negative 3. Okay? So I'm going to take this equation here and plug in -3 wherever I see x. Now, is this equal to 0? Well, let's see. -3 squared is going to be +9. 8 times -3 is -24 plus 15. Now, is it true that 9 minus 24 plus 25 equals 0? Let's see. 9 minus 24 plus 15. Well, yes, it is. It is equal to 0. So this works out. Now let's test the other number. X equals -5. Let's see. -5 squared plus 8 times -5 plus 15. Is it true that this equals 0? Let's see. -5 squared is +25 minus, what is that, 40 plus 15. Is this equal to 0? Let's see. 25 minus 40 plus 15. It is. We get 0 again. So this works out. Okay, let's look at another example of using the same exact skill. So this is probably example number 4 by now. Example 4. Solve the equation m squared minus 5m minus 14 equals 0. So, in order to solve this equation, we need to factor that. So let's factor that. First question, can I use the shortcut? Why, yes, I can. Invisible 1. So let's find the two numbers that multiply to give -14, add to give -5. Let's see, 1 and -14, -1, +14, 2 and -7, -2 and +7. And look at that, I found my magic pair. 2 plus -7 equals -5. Done. So, I can use the shortcut, x plus, oops, I don't have x's. Crap. M plus 2 times m minus 7. From here, I can use the zero product property. Either m plus 2 equals 0 or m minus 7 equals 0. And from here, either m equals -2 or m equals +7 if I add 7 to both sides. Let's check. It is always, always, always a good idea to check your answer. So, if m is -2, let's check that. -2 squared minus 5 times -2 minus 14, is that equal to 0? Well, -2 squared is +4. -5 times -2 is +10 minus 14. Is that equal to 0? Why, yes, it is. 4 plus 10 is 14, minus 14, 0. Done. How about m is 7? Let's check to see if that's true. 7 squared minus 5 times 7 minus 14. Is that equal to 0? Well, 7 squared is 49. -5 times 7 is -35. And then minus 14. Is that equal to 0? Let's check. 49 minus 35 minus 14. Yes, it is 0. This works out. So we solve that equation correctly. Okay, let's look at another example. I think you need to see a lot of different examples of this because this is a brand new skill and it's pretty difficult to do. How about this? Let's say we are asked to solve p squared plus p minus 15 equals 5. Now, if you see an equation like that, notice what we have over here. We have a number over here that's not 0. Eventually, when we try to use the zero product property, well, we won't be able to because we need to have 0 on the right-hand side. So, in order to solve quadratic equations by factoring, you need to have 0 on the right-hand side. Okay, so have a little thought bubble out here. need to have 0 on the other side of the equation? Well, that's pretty easy to do in this case. In order to get 0 on the right-hand side of the equation here, all I have to do is subtract 5, right? I know this seems kind of counterintuitive. Mr. Wilsey, why in the world are we bringing all the stuff to the same side of the equation as a variable? Isn't that the opposite of what we're supposed to do when solving equations? Well, yes, you're right. But using this particular method, we have to have something equals 0. You always need to have something equals 0 in order to solve it by factoring, because that's the only way you can use the 0 product property. So here, let's factor this guy. Let's factor it. Let's see here. What two numbers multiply to equal negative 20, add to equal invisible 1? Well, let's see. 1 and negative 20, negative 1 and positive 20, 2 and negative 10, negative 2 and positive 10, 3, no, 4, yeah, 4 and negative 5, negative 4 and positive 5. Those are all the factor pairs there. Which pair adds up to invisible 1? Well, negative 4 plus 5 equals invisible positive 1. So I can use a shortcut because there's an invisible 1 out here in front of the p squared. So p minus 4 times p plus 5. That means that, split this, either p minus 4 equals 0 or p plus 5 equals 0. So p is either positive 4 when we add 4 to both sides, or p is negative 5. Done.